You may have heard that global warming has stopped. This claim has been repeatedly promoted by climate skeptics and subsequently reported by various media outlets and blogs, the idea being that this contradicts everything that climate scientists have been telling us. Well, in February of 2010, those pushing this argument heard music to their ears when the BBC asked Phil Jones, the director of the Climate Research Unit at the University of East Anglia, if he agreed that from 1995 to the present, there has been no statistically significant global warming. Dr. Jones responded, yes, but only just. He then said that the trend is positive, but not significant at the 95% significance level, and that achieving statistical significance is much more likely for longer periods and much less likely for shorter periods. Well, this is a very honest answer to the question, although he probably could have done a better job communicating what it actually means. Oh well, here's the headline. The Daily Mail proclaims, ClimateGate U-turn as scientist at Center of Roe admits there's been no global warming since 1995. This so-called admission to a lack of warming spread like wildfire. If you do a Google search for Phil Jones, 1995, no global warming, you get over 3 million hits. Well, what does this all mean? No statistically significant warming since 1995. Has global warming stopped? Is this a huge revelation that contradicts climate change science? Here's the data set in question, the Hadley-CRU land ocean surface temperature anomalies from 1995 to 2009, one analysis of the last 15 years of temperatures. The red is the trend line, the so-called line of best fit. You can see that the temperature trend is rising over this period, but as Dr. Jones points out, not at the 95% significance level. But what does statistically significant even mean? Really, the statistical test helps us to decide whether we think that the temperature trend is actually positive or whether we are likely to see this positive trend simply by chance and that really there's no trend at all. In other words, that the line is really flat. The 95% significance level refers to the notion that there's some point at which we decide that a trend line is indeed positive and is statistically significant, or that we can't conclude that it's different from a more or less random cloud of points, and thus it's not significant. It's important to point out that this cutoff point of statistical significance is really quite arbitrary, and by convention tends to be 95%. Actually, Dr. Jones has inverted this number. It's technically 5%, but I will be consistent with his terminology. If you want to learn more about statistical significance, be sure to check out the links below this video. Okay, so the trend for the last 15 years isn't significant at the 95% significance level, but it is significant at the 92% significance level. Quite close, as Dr. Jones points out. So what can we conclude about the data at hand? Does this mean that there's no warming? Absolutely not. It essentially means that there's not a lot we can conclude from this limited data set. We have decent confidence that the trend is indeed positive, and we certainly cannot conclude with confidence that the trend is flat either. The problem is that 15 years is a very short period of time when we're thinking about climate. Climate is all about averages and long-term trends. With lots of year-to-year variability, it's difficult to capture trends on such a short time scale. To understand this, it's worth examining the difference between long-term and short-term trends. So to do this, let's briefly leave the real temperature data behind and first make up some data. So we know that global temperatures are affected by all sorts of cyclical processes, such as those associated with El Niño and other large-scale heat exchanges throughout the world, in the 11-year solar cycle, etc. So let's pretend that there are 4 important factors that cause temperature to go up and down, and which interact to produce chaotic-looking temperature fluctuations. Then let's add on an increasing trend, say from rising greenhouse gases like carbon dioxide. When we add all of these together, we'll get a very complex response with lots of wiggles, but we know the overall values have to be increasing because we've added in a positive trend. So here's the result of combining all of these factors that influence our fake temperature data. We see the long-term increase, of course, but also several negative short-term trends. So if we only looked at a short time period, we really can't say anything at all about the long-term trend. From this figure, you could conclude whatever you want if you only looked at short time periods. Bottom line, short time periods are not informative. But 15 years? Seems like a long time, right? Let's first put this into perspective by showing the temperatures since the start of the 20th century. Okay, things look a little different now. The positive temperature trend over this period is significant at the 99.999999999 significance level. Not even kidding. But there it is in red, the trend line for the last 15 years. So the logic goes, 15 years without statistically significant warming means that global warming has stopped, right? or at the very least that it fundamentally contradicts what climate scientists have been telling us. So let's put this logic to the test. If we go back through the temperature data, we find that there was no statistically significant warming during the 15-year period from 1979 to 1993, and again, no statistically significant warming from 1972 to 1986, and from 1966 to 1980, and we could keep going back if we wanted. So hold on, according to this logic, global warming has repeatedly stopped all the while temperatures have continued to rise. Makes no sense, right? Right. This is all because short-time trends don't tell you anything. It's really a meaningless argument. So that's take-home message number one, that 15 years of temperature data by themselves really truly don't tell us anything about trends in global temperatures. Okay, so is there a better way to judge whether the last 15 years contradicts a warming world? Why, yes, there is. Let's check it out. One way is to plot temperature data and stop before 1995. So here's the most recent period of rapid warming, beginning with 1960. You can see a very statistically significant positive trend. We can then ask if this trend is indeed true and is continuing, what temperatures should we expect in the near term after 1995? And that's what those dotted lines represent, the range of temperatures where we would expect to find 95% of future values if this trend is actually continuing. This is known as the 95% prediction interval. So let's plot the data since 1995 and see where they fall. If they fall within the dotted lines, then they are in agreement with continued rising temperatures. Well, would you look at that? They're well within the range, suggesting that there's absolutely no reason to believe that this warming trend has stopped. Moreover, the last 15 years have been at the upper end of this range. And here I've picked 1960 as a starting date, but you could pick any starting date so long as it's not too recent. And you get the same answer, that by themselves, the last 15 years are fully consistent with what we would expect with continued warming. So there are two take-home messages here. Number one, as mentioned earlier, is that 15 years of data really is too short to tell us anything about climate change. The previous example, showing how global warming keeps on stopping while temperatures keep on rising, clearly demonstrates this. The second take-home message is that temperatures over the last 15 years are entirely consistent with a continued warming trend. So no, unfortunately, global warming has not stopped. Overall, this is really a classic example of how science gets distorted. Making sweeping conclusions from short-term data sets is one of the most used tricks in the skeptic's playbook. Don't fall for it. Fool me once, right?